we've got Andrew on, and while he's getting himself all set up, I'll read a little introduction. So density measures how people use space in real time without invading privacy. Using proprietary depth sensors and deep learning algorithms, the platform accurately and anonymously counts people in real time. Organizations use density to improve efficiency and enhance the occupant experience in their buildings, workplace, and real estate. And I'm pleased to welcome Andrew from Density on. Andrew, are you there? I see you're muted.
Yes,
there
can you see me?
Yeah.
Can you hear me okay?
Yep. Look good, sound good.
Cool.
Welcome to our event. I'll take it away.
Thank you. So I can't see anybody, so I can't really say it's nice to see everybody, but it is really nice to see everybody. I thought that I would kind of walk you through some interesting product stuff and show you some actual live applications of some of the technology that we build. My background is in web application and software development. But back in 2013, 2014, we wanted to know how busy our favorite coffee shop was. And it was really irritating that we would walk through 5 blocks of snow with negative 10 with the wind chill in upstate New York, only hit a 20-minute line at our favorite coffee shop. It was called Café Kubal. And we thought it was really irritating that there was an API for the number of, there's an API for the weather that we were walking through, but there wasn't an API for the number of humans in a space. And so it's very hard to figure out how many humans were in a space. So began what we thought was going to be a weekend project, and has turned into the last more than half a decade of my life and of some of my co-founders. So my name is Andrew Farah. I'm co-founder and CEO of a company called Density. I thought I would show you kind of how the technology works, and then how it gets applied specifically to workplace and commercial real estate. So let me just, I'm going to share my screen, but before I do, I just wanted to call out, if you have questions live, just toss them in the Q&A and I'll incorporate them into what I'm presenting. It's super helpful if you have some questions to toss them in, just to make sure that I cover them all. Right, so I think I find presentations to often not lead with product, to just sort of start with like, what is it that you build and how does it work? And so I've kind of structured this to be predominantly focused around like what we build and how it works. I love the presentation that this one sort of customer put together. And so I thought it was a really good illustration of how the system works. So we build technology that figures out how many humans are in a space. We build both the hardware and we build the software. So this guy, this guy actually runs happens to run a ski chalet, and he's using our product to help keep people safe as he reopens, which is a common use inside corporate office and workplace. What you'll see is that as he walks through the door, the count goes up by 1. Now that very simple concept of +1, -1, as he comes back through that second door, there's another sensor above the point of entry, and it decrements by 1. That very simple process of +1, -1, the number of things that have to go right for that to work is remarkable. It's just like way too many things have to go right. It's a borderline miracle, low grade, don't write home to mom sort of miracle that works. Now, the way that this is happening is essentially through an entry-based sensor. So we build 2 sensors, which we believe are the sort of fundamental building blocks for measuring how a building gets used. This one device on the left, it's about this big, gets mounted above a point of entry, kind of like a nicely designed shower head. And my head of marketing hates when I call it a nicely designed shower head. But we bounce infrared laser light off of objects as they walk through a doorway. And a common theme in, I think, any sort of analytic system, especially when it comes to sensors, is that people will say, well, it's a vision sensor. It's a computer vision sensor. We use, complex machine learning to figure out utilization. We like to just say, like, just show me what the sensor sees. So I thought I would show you what the sensor sees. The one thing that we've learned over the last, I don't know, 6-7 years of trying to build an occupancy-based system, a real-time occupancy measurement system that doesn't invade privacy, is that humans are extraordinarily weird. People just do strange stuff in doorways. They do strange stuff in space. And so what you can see here is actually what our devices see. This is infrared laser light bounced off of objects as they're moving beneath the point of entry. And what this allows us to do is essentially make sense of complex human behavior. You can see a television in the top right. You can see a trash can in the bottom right. Humans moving in different directions, people taking phone calls, bumping into each other, bringing plates, door frames, the door frames themselves. And then even in the bottom left, you can see a dog. Density doesn't count dogs. It actively ignores dogs. But it's the type of thing that can create a lot of false positives. So a lot of promises in space utilization, a lot of promises in accurate count for sort of many systems out there. But doing this right requires some really remarkable precision and getting rid of all the things that are non-human in the scene. The last thing I'll note, and then I'll move on to our open area sensor, is that most buildings, when there's a reasonable expectation of privacy, we believe it's really important to build anonymous at source technology. So what you're looking at is not anonymized, it is anonymous at source. This also, I have a 3-month-old who, if she starts crying, I might have to go pick her up, and I'll bring her on video so you can say hello. So we have an open area sensor that is designed to measure any open space. And what's really remarkable about this system is that this is non-optical. It's based entirely on radar. You can see John in the top left and Carissa, and as they move into the space, they can be pictured in 3 dimensions. All of this without invading their privacy or knowing gender, age, or ethnicity. This is the closest thing to magic that I will likely ever work on. We think that this is going to meaningfully change how people understand and test space design, and the people in it. Okay, so I'm gonna have to go get my daughter and bring her back. Her name is Josephine, in case you're curious. We call her Jo, but I apologize. I'll be right back.
This is a virtual demo day first. We've got a child joining, and I love it. This is the times right now. Looking forward to adding Josephine to the conversation.
Cool. We'll be right back. Let me just go on mute real quick. I'll let this play while I'm doing that. Okay, this is Jo. She is truly brand new, and she has awesome pajamas on. But she just went down for a nap and isn't too pleased about it. So I'm gonna see if I can calm her down in her bouncer here while I'm talking. All right, how is the crying in the background? Is it not too bad? These are noise canceling. So.
It's getting better. Yes, it's kind of quieting down.
Okay.
Yeah.
All right.
There's not much we can do, right?
No, seriously. So, by background, I think in workplace, something that we didn't really realize is that there is just an enormous amount of unused space. In the U.S. alone, there's about $1 trillion of space that has nobody in it. And we think that that's a problem that's eminently solvable. There's a question about, oh goodness. I'm so sorry. let me see if I can quiet it down in her sleep. Just one second.
Hey folks, just we're gonna give Andrew a second to get little Joseph's feed squared away. So thanks for hanging tight with us. I just chatted a link to Density just to learn more about their products, so that way you guys have it handy.
All right, we're gonna try one more time. I thought I would jump into, thank you for the understanding, super appreciate it. She will probably cry a little bit in the background. You may see me bounce around, but I am gonna show you some stuff that I think hopefully will be kind of compelling. So let me just jump into, we essentially take all this data and turn it into utilization metrics. But the really cool stuff is, like, what would happen if you just put open area measurement and entry-based measurement directly onto a floor plan? So instead of just a BI tool, which we think is like super cool and super fun, we built this. So while that's loading, what you're gonna see is essentially open area measurement on top of a floor plan. This is an actual floor plan. And what's really cool is, like, I can move around this space, and I can zoom in, but that is an actual human wandering around an actual space on a floor plan. And what's remarkable is that not only can we do this in motion, we can also do this in 3 dimensions. So let me kind of pull this back. And if you play Minecraft, like, this is awesome. Like, this is Minecraft. This is like the coolest thing, I've like ever seen. And it's just never been possible before, to be able to see people in space in a way that is not just sort of numbers and stats. And it's also totally anonymous. I've got no idea who this person is, but I can understand that this person is sort of wandering through a space. And so when we think about scaling this, we're able to do some very large scale deployments, essentially with without having sort of a complex installation and setup process. So this is the actual method of installing and doing setup and calibration with our devices. And what's really cool is if I sort of toss some people in here, you essentially can see folks as they use space. So this is cool, and it's like helpful to be able to like, like simplify the process of like visualizing and seeing how people will use the space that you have. But the thing that I love about this is that as you get more substantial coverage, we can start to see overlapping fields of view. And our devices can see with a remarkable distance. So the higher up that these things get installed, the wider the fields of view, the broader the measurement. And so you don't need to necessarily overlap quite as much. And so, okay, so this is sort of like how we do like planning and deployment. We could take like thousands of sensors and we can outline sort of your entire portfolio in a single day. But we thought, well, if you could see the number of people that are in a space, like just like visually be able to measure people in space, why not A/B test actual assets? So we're going to create a room. And then inside that room, we want to add maybe 2 desks. These like standing desks. Joe is thankfully being super sweet right now and has fallen asleep in her bouncer. And I'll make sure that I bring her back up to say hello before the end. Michael Beckerman says best demo ever. That's definitely Joe's fault, not mine. I will talk about installation and power as well. So, so what's cool is if we sort of toss somebody into this room, you're going to watch it go from purple, light outlined purple, to dark. Let's see. So interesting. You all might be actually seeing a bug. Let's see if this, oh, there we go. Okay. So what's cool is that you can essentially measure how an asset is performing and A/B test physical space. So if we have somebody in this seat and we have somebody in this seat, you can see that these two spaces are being, these two desks are being used. And if we have nobody in this third seat over here, you can see that that space is unoccupied. Now, the coolest thing about this is that once you're in there, not only can we measure if a desk is in use in real time, not only can we do, you know, is a room in use and are the desks in use all with one sensor, we can also do dwell time. So how long are you spending in one particular area? And we can do this without invading privacy. So again, you know, all of this is anonymous. All this is without invading privacy. So to be conscious of time, I want to make sure that I answer some of these questions. I don't, so I don't know how to, one of the questions is, how do you get a child to stop crying so quickly? Honestly, she's like the best. I'm just, you know, I'm just around as an attendee to like the best kid ever. How are these installed and powered? So installation and power, these things are power over Ethernet. So we do low voltage Ethernet back to a switch, or you can go even to an outlet and then connect to Wi-Fi if you'd like. But power is a really important concept. I think a lot of people are tend to look for peel and stick systems. So they want to just like take a thing and put it on a ceiling, or they want to peel a thing and stick it on a wall and then use battery to be able to measure utilization. One of the things that we tend to see is that's really great for piloting and testing. It's really good for space studies, which is a sort of the historical norm for space use. But the thing that you'll tend to notice is as those systems start to scale, they die on the other end. So as you scale, the larger the scale of the deployment, the bigger the problem you create later on, because the batteries start to die. And so if you do 2,000 sensors with peel and stick, then you have to go back and you have to swap them out. And at some point they become essentially these obsolete bricks that are installed all over the place. We like to think like longer term. You know, our intent is to design a system that is modernizing how a building actually is used, modernizing the infrastructure of a building, because 5 years from now, there won't be a building that is designed, built, or used whose performance is not measured by some autonomous system. And we think that the pandemic is kind of accelerating that timeline. And the last thing I'd say about installation, you know, you can go from I want to scope to I want to be installed in like 2 weeks. Doesn't take a ton of time. Also, the mail person is here, and I have a dog who's going to bark at that person for at least the next 30 seconds. Installation and power is something that we can really help you through, and we have an international network of people that can do the work. Let me stop sharing real quick, and I'll come back to the applications in a second. The tenant clients planning to proactively plan their space usage going forward post-COVID. As so many companies are rethinking how much space they will use, and how does density help them with their future occupancy planning? Yes, so it's a great question. So let me share my screen again. This is Signal, which I just want to say for a second, this is like unannounced. So I'm showing you something that has not been shared with anybody but some of our closest relationships. This is a system that, you know, we had a customer who, I'm going to get to radar for room sensing and infrared for doorways in just a moment. So we had a customer who said, look, I've got, you know, we have all these beautiful analytics and dashboards where you can say, you know, I want to I want to be able to understand utilization at a really large scale. I want to be able to like create these reports that show visitation, total square footage, roll up. These are all great reports and super fun. But we had a customer who was taking data across 15 locations across 3 or 4 states, pulling it into a CSV, and then trying to plan their return to office with the data. So the way this works is they have a national rollout. They set a maximum capacity of 40%, so no greater than 40% capacity. And what they wanted to figure out is, as they reopen offices, is that capacity are they exceeding that capacity? And badge data, just to quickly call out badge data. Badge data is really good for one-way entry, but we tend not to badge out of buildings, nor do we badge into conference rooms or other spaces. And so badge data really only gives, did a person visit? It doesn't say, what is the occupancy over time? What's the utilization over time? So we took the data. We have a real-time API. So all the data that we generate is made available through an API. And we thought, we're just going to make your job like substantially easier and replicate the system that you have put together through Excel. And you set a maximum percentage peak occupancy, and you can track percentage utilization across all of your locations. Now, what's really cool is you can sort of use this like fun, by the way, this is undesigned. This is really just for usability. But the thing that's really cool is that you can say, okay, I want to look at like the advisory team, or I just want to look at the corp team. It looks like I've got no one who's on the corp team. I have not opened these buildings yet. These are all closed. And yet still people are showing up. So average occupancy has a handful of folks that show up, even though this office has not been formally opened. And if I go into, I think it was this week, you can see if you exceed the peak occupancy, in this case, they may have set it for a smaller number of 30%, they could very quickly say, I need to rebalance or load balance the humans that are showing up. I need to slow the rate of entry in one particular office and increase the rate of entry in another office. The other really cool thing is that counting 0 is incredibly useful. Knowing where there is waste is an awesome, awesome data point. And so they are able to essentially filter by, what is not being used, but is still open. This is a 200 capacity, floor or building. These is a 100 person, 200 person, and so forth, that are barely being touched, but are still being cleaned. They're still being serviced. They're still being staffed with security. They're still being. So anyway, the point is, once you understand how a building gets used, or buildings or a portfolio, you can start to make really meaningful decisions, not just COVID related, but just about how you service, use, or otherwise interact with that space. All right, so there's a question about why use radar for your room sensing versus infrared used in doorways. So the devices, so these two sensors, entry and open area, are complementary, meaning we have a lot of customers who will come in saying, I really need open area, or I really need entry. And what they really need is the other sensor. We have some customers who say, I need both. And what all they really are trying to do is floor and building level occupancy. And so all they really need is entry. And as long as you have a device at each of your entry points, we can in real time figure out how each of these spaces are being used. So I would say I just think like there's a lot of square footage in between the points of entry. There are a lot of rooms that are really large, a lot of rooms that are really small. The technology you use shouldn't matter. I mean, it matters insofar as it's real-time, accurate, and anonymous, which is why we always encourage clients to say, show me what your device sees. Because if someone shows you what their device sees, 9 times out of 10, it's going to be a camera that's anonymizing at the edge. Or it won't be accurate because it'll be a passive infrared sensor or something else. So we would much prefer that you all bring your problems, or a customer brings their problems. What are you trying to solve? What are you trying to measure and why? And then we can sort of make a recommendation on the right technology. What's the fewest number of sensors you need to get the most coverage for the use case of your choosing? And that's kind of one of our primary commitments, is that we try to design devices that require the fewest number of sensors for the most coverage. Could you share some examples of how companies are using the data from density sensors for non-social distancing purposes? Yeah, so we work with, let me stop sharing, I'll just kind of speak to this real quick. So we work with some organizations who, I'll give you a specific example. We saved a customer $3 million on a $25,000 deployment. So they had an office, and they were, this is pre-COVID, they have since scaled nationally, but pre-COVID, they had done this deployment, and it was, I don't know, 30 or some odd devices. And they were measuring floor level occupancy and utilization. And they were about to sign a lease. I've got about four more minutes. So I'm gonna make sure that I address this question and any that I may have missed. As they were getting closer to signing the lease, the reason they were gonna bring on this new office, which was adjacent to the building with our sensors installed, is because they were hiring something like 800 new folks. Density System noticed that their peak utilization over a 90-day period was 37%. Their busiest moment was 37% utilization in the office that they had already had. And so their VP of real estate took it to their COO and said, look, I think I could put all the 800 folks into this office that I have here. We can walk from this lease. And he said, what's the value of the lease? He said, well, it's $1 million a year on a 3-year term. And the COO said, walk. And I got a phone call the next day. He said, Andrew, Density saved me $3 million on a $25,000 spend, or whatever the pilot project was. And I said, wow, that's awesome. How? And he explained the story to me. The point is that a lot of people think like space consolidation is like the primary thrust. Our objective is not to consolidate space. We don't think that you should just get rid of space. In many cases, actually having a lot of space might actually be an important strategic decision. We just don't think that you should build space without measuring it. And so we try to design technologies that are sort of infinitely scalable. And then we try to make that data as easy to consume so that it can inform actual decisions. We think it's nuts that for thousands of years, we've been building buildings without knowing how they get used. And we don't think that there's a future in which humans don't eventually figure out how to measure the space that they build and use. It's really just a question of the technology you use and whether or not you result in kind of mass surveillance with camera-based systems. And I guess the last thing I'd say is like a lot of architects, if you talk to them, a lot of designers will say, you know, one of the most unfortunate things is that we find ourselves with point in time designed. Yeah, exactly. If it's not measured, it can't be optimized. Peter Drucker is this awesome. Peter Drucker is just by himself very cool, but he has this great book. And in it, he says, I believe the quote is, you can't manage what you don't measure. And so the fact that we have organizations and customers that have 75 million square feet of space, 100 million square feet of space, 347 million square feet of space, and the way that the decision is made on what to do with the space inside is based on an observational study of someone a consultant coming in with a clipboard, seems completely insane to me. And so we try to make the data not only easy to use, not only scalable, but really try to help inform how people are using space. One really important question about our employees ever concerned about being tracked. So if you share what the devices see, employees universally go, wow, that's awesome. That's number one. Number two, so transparency is really important. And then number two is if you give them the data back, if you provide value back to them, they will also be thrilled by space measurement. So is that desk available? Is that conference room available? Is that conference room that VP secures on a recurring basis while they're traveling in Taiwan, which perhaps maybe isn't happening quite as much these days? Is that space actually being used, or is it just booked by someone who isn't physically there? How long is the cafe line? These are all things that you can answer, and I can even just quickly show you. I know we're right about a time, but this comes standard. This is a Density's live view, and in real time, we can help show your employees on existing displays or on a mobile application what spaces are actually available. So don't track them, be transparent, and ultimately be as useful as you can.
Thank you, Andrew. mostly important, thank you, Joe.
Yeah.
Folks, the chat's in the link on how to find more out about density. We've got Linda and Blanca getting started. Oh my goodness.
Yeah, she's super cute.
Oh, she is indeed.